Hi, in this video, we are given the following problem as x minus y minus z all squared plus 2x minus 3y plus 2z plus 4 all squared plus, open bracket, x plus y plus z minus 8 all squared is equal to 0. Now, before attempting to expand and confuse yourselves, an important point to note is that whenever you're working with an equation like this, where it is all being separated by an operator, so this is a plus sign. Well, most of the cases it would be a plus sign. So as you can see, these three, well, let's call them expressions, are being separated by plus signs. Now what we could do is to actually equate each of them separately to 0. Now the reasoning behind that is that, seeing that there isn't any negative, if there was a negative sign between one of these, we could not do that. However, they're all positives, so that means each one of them separately has to be equal to 0, and that is pretty useful in helping us to solve this problem. So let's equate each one of them to 0. So x minus y minus z is equal to 0, and 2x minus 3y plus 2z, this is actually a z, plus 4 is equal to 0, and lastly x plus y plus z minus 8 is equal to 0. And we're ignoring the square because that was, well, that is irrelevant in this instance, because what is in the bracket is already equal to 0, so we could equate these to 0. Now what I'm going to do here is to actually, let's label these. So this is equation 1, equation 2, equation 3. Now that will come in handy whenever we're solving for these equations, because we're going to have to use elimination method of simultaneous equation to solve these. All right, so let's add equation 1. So let's add 1 and 3. All right, so in adding 1 and 3, we would be left with x minus y minus z plus x plus y plus z minus 8 is equal to 0. And as you can see, we have a negative y and negative z, so those would cancel. So 2x is, well, 2x minus 8 is equal to 0. So that would mean x is equal to 4. Now that is one of our solutions. And when x is equal to 4, we could actually plug that into the original equation and get rid of the x values. So in doing that, we would now be left with, well, two different equations. We would be left with y plus z is equal to 4. Now this is by using a substitution in the first equations that we had after we solved for x. So z plus y is equal to 4, and 3y minus 2z is equal to 12. So let's actually label these equations. So this is now our new one, and this is 2. So let's use simultaneous and elimination method. So what we could actually do is to multiply the first equation by 2. So let's actually multiply this equation throughout by 2. So we would be left with 2y plus 2z is being equal to 8. And the second equation is 3y minus 2z is equal to 12. And I'm going to simply add both equations. So that would leave us with 5y being equal to 20. And from this, we could see that y is equal to 4. All right, great. So when y is equal to 4, we could actually just use a direct substitution in any one of these equations to solve for z. So as we can see here, y plus z is equal to 4. And if y is equal to 4, so y plus z is equal to 4. And when y is equal to 4, so 4 plus z is equal to 4. So that would mean z is equal to 0. So therefore, the solution for this problem is x equal 4, y equal 4, and z equal 4. So the solution x is equal to 4, y is equal to 4, and z is equal to 0. And you could actually substitute both of these or all three variable values into the original equation and you would get 0. So thank you for watching. If you enjoy these videos, please be sure to leave a like and a comment down below. It is much appreciated. See you in the next one.